Okay, ladies and gentlemen, this is 7.4 midpoints and medians of triangles. We've done an investigation, a little bit of watching on Geometer's Sketchpad, and we figured out some of the properties of medians and midpoints and what happens when we have a perpendicular line to a line segment that adjoins adjacent midpoints and all of those good things. We're going to make sure that we all have the same notes. So in the first box, a midpoint is a point that divides a line segment into two
Equal
segments. So all you need is a line segment, which you draw by having a dot on either end. And then we're going to draw a midpoint. We'll call that midpoint M. We'll label our endpoints A and B. And to show that it's actually a midpoint, it needs to divide the line segment into two equal parts. So AM has to be the same length as MB. And the way that we show that is by giving it two little hash marks there. Okay? Thank you very much. Next box. The length of the line segment joining adjacent midpoints is half the length of the base. Now, for that one, you're going to want to draw a triangle. It doesn't have to be any sort of special triangle. Okay, just a random triangle is good. We'll label our points A, B, C. And we'll draw a midpoint on one of the side lengths. Now, how do I show that's a midpoint again?
hash mark.
Two little hash marks on either side. Okay, I have to do that in order to show that it is a midpoint. And now I'm going to draw my median, which is the line that goes, the length of adjoining adjacent. Sorry, I need two midpoints first. So let's do another midpoint here. And we can give him one hash because I don't want it to look like it's the same as these guys. Okay? And we can label them D, E. And I can draw a line across there. Okay, and now what I've shown is that DE is half of AB. Okay, so how you would write that is you would say DE. That means the measure of the line segment DE, the length of DE, is 1/2 of AB. This all goes in that big second box there. Okay? Now the second thing that we have in there is that the line segment joining two midpoints has what? The same slope as the base. So to show that, all I'm doing is putting my little parallel markers on those two line segments, okay? Now you could have drawn your triangle any which way, any which direction. You could have picked any median, any of the three. Sorry, not medians. Scratch that, reverse it. You could have picked any of the two line segments that attaches adjacent midpoints. And you would get the same properties, okay? DE is half the length of AB. DE has the same slope as AB. Okay, that's all you need in those boxes. Next box. The height of the triangle formed by the line segment joining midpoints is... So again, we can draw any triangle. Okay, we can call that triangle A, B, C. And we have the same thing. We have the line segment joining two midpoints. So let's give a midpoint here and a midpoint here.
You have to do two hashes like if yours is like the number 1, 2.
It only is what you say that it is. So if you don't tell me that they're equal, then they're not equal.
What?
No, you need to have an indicator that these line segments are equal. And you need to have a different indicator to show these line segments are equal. That's what proves that D and E are midpoints. Okay? Now, this drawing is going to look a little bit funny to you because we haven't really quite learned this yet. But the height of this triangle, the altitude, is actually the line that goes through and meets meets the base at a right angle. Okay? So I've got a new point here. You can call that F. You can call that FG. And what we've learned is that AF is half the length of AG. Okay? Now that also tells us that AF equals FG. They're the same length. Okay? So pay attention, make sure you're understanding this. AF, which is the height of triangle ADE, is half the length of AG. AG represents the height of triangle ABC. Okay? And in your last
We don't
section,
have a point F.
no, you construct it, you make it.
Oh, there.
The last box is about the median of a triangle. What does the median of a triangle do to the area of the triangle?
Divides the area of the triangle.
The median of a triangle divides it by what?
I don't know the area.
Divides it by 3, divides it by 4, divides it by 7.
Division is
By
2.
No, it's not always. Divides by 2. There's a special word when you're dividing something by 2. It's
Double.
bisect. Double would be timesing by 2. Bisect is dividing by 2. So you need to have the median in that last box. The median of a triangle bisects the area of the triangle. And again, we can draw any triangle, ABC. And remember, the median is a line that goes from a vertex to the midpoint of the opposite side. So this right here, BD is a median of triangle ABC. And what we've learned is that the area of ABD is half the area of ABC. Okay? So we're looking at area. This is a subscript. ABD comes below area, so it's a subscript. The area of this triangle is half the area of this triangle. Okay? Same is true for the other smaller triangle that we made. The area of BDC is half the area of ABC. Alright, so that's what that box should look like. You now have your notes. Basically, we're going to be using all these properties, so go ahead and take 30 seconds, read through them all again. Your goal is to memorize all of those properties and be able to use them to solve problems within triangles. Go ahead. Okay, well, let's apply some of those things that we've talked about. You can already see in the diagram, without even reading the question, that we have two midpoints. What are the midpoints? D and E are both midpoints, and the line segment DE joins the midpoint. So what's happening to the triangle ABC? What other things do you know about what's going on? What other things could we find out?
It's getting dissected into different shapes.
Okay, so it's been cut up by a box there.
Yeah, the 290 degrees.
G is 90 degrees.
Yep, we know the angle that DG and BC are perpendicular to each other.
DE is half of BC.
Nice, we know that DE is half the length of BC. That's going to help us. What else do we know? What about height or altitude? Do you know the height of the triangle?
25. Well, for the box is like 25
It's
from the.
5. It's
Ah,
2.5.
so the height of the triangle is double that 2.5, so it's 5 meters. I should put my meter sign there. Okay, good. So you've looked at the diagram, you've observed a bunch of things, and it makes sense. So now the problem should actually be quite straightforward. Let's read. In areas that get a lot of snow, cottages are often built with a triangular shape called an A-frame. It's A-frame construction. This shape helps prevent damage from heavy loads of snow on the roof. So this diagram shows a cottage. Find the width of the floor of the upper room in this cottage. Think about it. Find the width of the floor of the upper room of this cottage.
The width
The
of the
upper
floor
room.
6.
So what are we of the upper room? So you have a lower room, ground floor, and upper room?
3.
2. 3.
How do you find
It's 3.
Finding.
Hundo P.
What are we officially finding? We're finding the length of DE. That's the floor.
This is your lunch.
That's the floor of the upper room. Okay?
Is she still here?
Good. So, how do we know?
It's 3.
How do we know that DE is going to be half of BC? How do we know that?
Because D.
Tell me things about the triangle.
Because it's a midpoint.
Ah, because D and E are midpoints. That means,
And the length of the line.
so we could say since BD equals DA, and AE equals EC, D and E are what?
Half.
What are
The
D and E?
midpoint.
They are midpoints. Good, okay, we need to explain our reasoning for things. Alright, so from the properties of midpoints, of the sides of triangles, DE must be half the length of BC. So, by the properties, whenever we're talking about characteristics of things that are always true, it's a property of geometric figures. By the properties of midpoints, of sides of triangles, comma, DE equals half of BC. Okay? Now we know that BC is how long? What's the measure? 6 meters.
We just looked
So half of 6 is 3 meters.
That's actually smooth.
Therefore, the floor of the upper room, or loft, the upper room is 3 meters wide. All right, B. That was not too bad, okay? B says find the height of the upper room. Okay, so this was A. Now we're on B. Find the height of the upper room. We already did that on our diagram. We thought through it. And now we're just going to show using properties. Okay? Ready? We did it the same way. We started with our midpoints. And we already proved that up here. So now we just have to say since D and E are midpoints, D, E, I'm going to just use this word, bisects the height of triangle A, B, C. Okay? So, the height, I'm going to use H, the height of let's assume we know that this is true. These are all 90-degree angles, okay? So we know the height of DG. If the line were going through the middle there, the altitude, DG would be the same height as that height, okay? So we're just going to say DG.
So G is the 90-degree line.
DG is this line segment right here. DG is half the height of ABC. Okay? That sentence makes sense to you guys? DG is half the height of the big triangle.
Got it.
Okay?
What?
So now all we have to do is sub in the things that we know. DG is 2.5 meters. DG is 2.5 meters. And that's half. I'm just going to use H of ABC. And now in order to get the height of the triangle ABC, this is a bit tricky for you, but what do we have to do? Right now it's being multiplied by a half. So we need to divide it by a half. Not divide it by 2. Okay, we need to divide it by 0.5. Alright, so actually dividing by a half is the same as multiplying by 2. So I'm going to multiply both sides by 2. On this side, I'm left with just the height of ABC. And on this side, 2.5 times 2 is 5. Okay? Therefore, the height, finish it out, of the cottage is 5 meters. Alright, example 2. We're dealing again with medians of a triangle. And all we need to do is show that the median bisects the area of a triangle. So we already did this in our investigation. We're going to do it now, okay? First, we need to know what a median is. So take a little note here at the top of your page or in the box. It doesn't really matter. There you have lots of space there. So a median is the line segment. The line segment joining a vertex to the midpoint of the opposite side. So it's a line segment joining a vertex to the midpoint of the opposite side. Okay? The next word you need is bisect. This just means to divide into 2 equal parts. Okay, you can divide things into 2 parts, 3 parts, 4 parts, 5 parts, a million parts, but when you do it into 2 as a special name, it's called bisecting. Alright, so we are going to use the area formula for a triangle in order to figure this thing out. Alright, so we have the median. We're going to make a median. So we're going to go the median from A. Now, where do I have to draw another point in order to get the median from A? Right, I got to bisect BC, which means I'm going to show that. And then I'm going to draw a line, and you guys should actually use your ruler because we're going to be measuring. Okay, I bisected BC. Now AD is a median of the triangle ABC. Okay? Now the formula for the area of a triangle, formula for the area of a triangle is, does anyone know what it is?
1/2 times base times height.
Okay, 1/2 BH, 1/2 base times height, or you could write that as B times H over 2. Okay, same thing. Timesing something by a half is the same as dividing by 2. All right. Well, I am going to we're going to draw an altitude. Okay, so an altitude gets us the height. Maybe I'll just describe what we're doing so far. In order to show that this is true, in order to show that this median actually bisected the area That means we're going to try to show that the area of ABD is equal to the area of ADC. Does that make sense? We're just showing that the area here is going to be equal to the area here.
Sure.
So in order to do that, I need to get the area of both triangles. Well, we already know that their bases are the same length. So we can say, since BD equals DC, the bases of triangle ABD and triangle ADC are equal. Go ahead and reread that, double check your picture, and make sure that makes sense to you. Okay? We're saying since BD is the same length as DC, this is the base of ABD, and this is the base of ADC, then those triangles actually have the exact same length base. So the B in the formula for one triangle is the exact same as the B for the formula in the other triangle.
They have to be.
Okay?
Because it's a median, right? Because
It's a midpoint. Okay? Because AD is a median, makes D a midpoint, means these guys are equal. So that's proven by the drawing already. We have to state it. Alright, what else do we know? That we also need to show there's two separate triangles. What do we know about the H of those two triangles?
It's the height.
The height of ABD is the same as ADC, and we can show that because to calculate the height, you take the altitude, which is this line. It's a perpendicular. Okay? So that red line that I've drawn is called the altitude, or in this case just the height is good enough. Okay, we'll call that point E where they meet. Okay? AE is the altitude of triangle ABD and triangle ADC. Therefore, the height of each triangle is equal. Therefore, the height of each triangle is equal. If the base and height of two triangles are the same, what do we know about the area of those two triangles? The areas are equal. Now, what were we actually trying to prove? At the very beginning it says, show that the median bisects the area of a triangle. So our last statement needs to be, therefore, the median bisects the area of a triangle. Now, notice we did not use any measurements. We did not use any numbers. What does that tell us?
It's doable. No, it's only algebra.
No,
Oh.
it's not. No.
So we did it in
It's all
one.
formulas.
We did it in one triangle, and we didn't use any numbers or measurements about this triangle. We just used B and H. So what does that tell me? Is this going to be true in other triangles?
Yeah.
Yeah. It's going to be true in every single triangle, no matter what the measurements are. Because this will always happen. They will always have the same length base. They will always have the same height. And since the area of a triangle is 1/2 base times height, and B and H are the same, then the area is the same in both triangles, which tells us that the median will bisect the area of any triangle. Okay? A bit complicated, but you're sticking with it and trying to make sense of it all. Okay, you've had the chance to look at example 3 on your own a little bit. Stephanie measured this right triangle. So the big triangle is a right triangle because that's 2 45s there, which add up to 90. She noticed that the median, so she drew a median from the top vertex to the opposite, the midpoint of the opposite side. She noticed that it bisects the right angle. That means it cuts the right angle into two equal angles, 2 45s. Okay? She conjectures that a median will bisect the right angle in all right triangles. Is the conjecture correct? We have some yeses, some no's.
One no.
In this example, the point of it is to say if you can find a counter example, so if you can find one right angle triangle in which this is not true, then it's false. Okay? So all we have to do is draw a right angle triangle in which this is not true. Well, the interesting thing about the right angle triangle that she drew is that it's also an isosceles triangle. So let's try to draw a right angle triangle that is not an isosceles triangle.
Oh, maybe anyway.
No. We'll see, Diego. We'll see.
Yep. Don't care what yours looks like, as long as it's not isosceles, it should work. Okay, now I've drawn a right angle triangle. Okay, I'm going to call this A, B, C. And we're talking about bisecting the right angle by using a midpoint. So, a median, sorry. Where am I going to draw my median from? I'm talking about bisecting the right
From
angle.
A to in between B and C.
A to C.
No, A in between B and C.
Her conjecture,
Oh, from B in between.
her conjecture is that the median is going to bisect the right angle. So my median is going to come from the right angle as well. So I need the midpoint of AC. You're going to measure that out perfectly. Okay. Mine is 15.2, so I get to cut that in half, which is 7.6. I'm going to show that I drew it as the midpoint by putting 2 hash marks to show that AD is equal to BC. And now I'm going to draw my median from B. And I've got 2 angles here. I've got a little angle here and a big angle here. Did my median bisect my right angle?
No.
No, it did not split it into two equal
What?
angles.
So Jake right?
Okay?
Jacob's right?
DBC is not the same as DBA. Alright? So let's put a
I was right.
in this
Fuck it all.
right
10 push-ups.
triangle.
We're in class. I don't do this.
In this right triangle, the angle DBC and the angle DBA are clearly not equal.
This is so good to be right.
Clearly not equal.
Understand for everyone.
Oh, I'm always right. I'm always right.
Therefore,
Why does it feel so good?
Debatable.
Predicted Boston would beat Toronto Game 7.
Gentlemen.
2 years in a row. Oh, got it.
therefore, a median does not bisect the right angle. That is not a property. Okay, that is only a property in an isosceles, in a right isosceles triangle, not in a right triangle. A median does not bisect the right angle. And then we should write that this is a counter example. This is a counter example. You can underline that word. And it shows that Stephanie was not correct. Her conjecture was not correct. Okay, key concepts down at the bottom. If you have this, do you have this? Okay, I am erasing. So key concepts really quickly. That's okay, you can get it off someone else. you have a triangle there, okay? And I'm going to buzz through this. I'll draw it in black again. Try to make it look kind of like yours. Okay, it's got a midpoint and a midpoint and a line segment, and it's got an altitude.
Why is it? Oh, never mind. Yes.
Okay, here we go. A line segment joining the midpoints of two sides is parallel to the third side. So we've got the line segment joining two midpoints is two things. One, parallel to the third side. And two, it is half as long. Alright, so what does that mean? The line segment joining two midpoints, that's this one right here, is parallel to the third side. So here's that mark, parallel to the third side. It is also half as long. So the length of this line segment is half of this length. Okay, so the base can be represented by 2L. That would make this line segment 1L. Okay? Now, again, next, the height of a triangle formed by joining two midpoints is half the height of the original triangle. The height of a triangle that was formed by joining two midpoints is half the height of the original triangle. So here we have the triangle that was formed by joining two midpoints. Okay, this top one. The height of this triangle, right, is half the height of the whole original triangle. Okay? We understand that?
Yes, sir.
Good. Another thing that we learned, the medians, because there could be three, right? The medians of a triangle do what to the area?
Split.
Special math word. Bisect its area. The medians of a triangle bisect its area. And the last cleanup note is just the last thing we did, which is what is a counterexample. A counterexample can disprove, so prove to be false, can disprove a conjecture or hypothesis. Ladies and gentlemen, there you have it. That's lesson 7.4. Your practice problems are the worksheet on the following page, okay? And you'll complete those on in your notebook. All right? Enjoy.
Okay.